evaluate polynomial functions today. So, first thing that you have to know is that if it shows up as a linear, like x plus 7, then the solution, the root, the 0, the x-intercept is always the opposite of that. And the other thing that we have to remember going into this is that that number is a solution if and only if your remainder is 0. So we want to evaluate this function when x equals 3. So remember, when it gave it to you as a linear, you had to change the sign. But this one is giving me the solution to check. So I'm going to set it up as normal. So the 3 goes in my half box over here. You have to look and make sure that you don't need any filler zeros. So I have an exponent of 4. Oh, the x to the third is missing. So I have 2x to the 4th plus 0x to the 3rd, x to the 2nd, the 1st, and a number. Okay, so everything else was there. So when you do synthetic division, remember that you are using the coefficients only. So my coefficients are 2, 0, 8, 5, and 7. I'm going to make a line here, and I'm going to put my little bar, and I'm going to write the word remainder. So whatever shows up right there is the remainder. You bring the first one straight down, and then you multiply. 3 times 2 is 6. Add down. Multiply. 3 times 6 is 18. Add down. And you get 26. Multiply 3 times 26, you get 78. Add down, get 83. You multiply 3 times 83 is 249. Add down, and I get 256. So I want to rewrite this and put my variables back in. So remember, when you put your variables back in, you start one less than your original problem. So this is 2x to the 3rd plus 6x to the 2nd plus 26x plus 83, and I have a remainder of 256. All right, so you have to, when you're not given it as a linear, you're just given the number, you have to remember that it's going to be the opposite. So if this is a 3, that means that as a linear, it looked like x minus 3. So one of the essential questions that we've been asking ourselves is 3 a solution or a 0 or a root of this? And we would say no. 3 is not a solution because my remainder is 256, aka not 0. So it is only going to be a solution when your remainder is 0. There's another way that you can do it. So the other way is you could use direct substitution. So it says use direct substitution and figure out what is the value of the function when x equals 3. So I'm just going to go through and I'm going to plug 3 in for x in my function. So I would just enter this directly into my calculator. So I have 2 times 3 to the 4th plus 8 times 3 squared plus 5 times 3 plus 7. Oh, and I get 256. What an interesting coincidence. So I've gotten super fast about doing synthetic division over the years. This way, I think, is really good if you have a decent calculator like the TI-30X2S or better. If you don't have a decent calculator, I would be super careful of doing this, and I might lean towards synthetic division. So whether you do synthetic division or direct substitution, I notice that I get a 256. So the 256 is the same as my remainder. For a lot of people, this is a very fast way to figure out if a number is a solution or not. And I can say 3 is not a solution because my answer is not 0. So just like above, it was only going to be a solution if my remainder is 0. And this method gets the same number as the remainder, so this can be a super fast way of doing it as well. We want to determine if the following is a factor of the polynomial. All right, so if we want to determine if it's a factor, apparently you could either A, run synthetic division, or you could plug -1 in for x. Either method would get the job done. I'm going to run synthetic division. So if that's a +1, that means my number I'm going to plug in is -1. Look at your polynomial. My exponents are going in order, so I don't need any filler zeros. Drop the first number straight down, and then multiply. -1 times 2 is -2. Add down. That adds up to -3. Multiply. You get a +3. Add down. Multiply. And add, and I get a 0. We're going to go ahead and put our other variables back in. 2x squared minus 3x plus 5. So determine if this is a factor of a polynomial. Yes, x plus 1 is a factor because my remainder is 0. The other thing that we had been doing is we had been sketching a graph. So if you wanted to work on sketching a graph, first thing that I would do is I would look at the end behavior. The leading coefficient and its exponent tells the end behavior, and that combination of a positive leading coefficient and an odd exponent means that it goes down and up. That 5 right there tells me my y-intercept. The point of running synthetic division is to test different possible answers. And so this passed the test because I got a remainder of 0. So this number right here, if it's a factor, then it means that that is a 0 or an x-intercept. I know that I have an x-intercept at -1, 0. In the next lesson, we're going to figure out how I can find my other solutions. And I can tell you that the next thing that we're going to do is you would either factor, or if it doesn't factor, then you would run the quadratic formula to find your other x-intercepts and solutions. So I don't know for sure what this looks like. I can tell that there's a y-intercept there. I can tell there's an x-intercept here at -1. Without solving this to find the others, all I can do is guess that maybe it looks like this. So this graph goes down to the far left and up to the far right. I have a correct y-intercept and I have a correct x-intercept. And until I learn a little bit more, this would be pretty reasonable. So we'll work on the exact points of these next unit. Determine if this is a factor of the polynomial. So I'm going to run synthetic division. Oh gosh, sorry, that is a -2, my bad. Check your exponents, 3, 2, 1, nothing. So I don't have any missing zeros. Your first number comes straight down. Multiply, -2 times 15 equals 30. Add down, that adds up to -2. Now multiply, -2 times -2 equals 4. Add down, you get a 7. All right, and then I'm going to backtrack and I'm going to correct my mistake. I'm sorry. Let's make that a -30, and when I add down, that's a -62. -2 times -62 is 124. And then when I add down, that adds up to 127. And when I multiply, -2 times 127 is -254. And when I add down, I get -252. I'm going to put my variables back in. So it's 15x to the third minus 62. I am a mess today. That's an x to the second. Minus 62x plus 127 minus, that's a remainder. So that means that I have to write it as a fraction. So a negative and subtraction mean the same thing. So I have my minus sign right here. And then my denominator is my linear factor right there. And I was trying to determine if x plus 2 is a factor. Nope. X plus 2 is not a factor because my remainder is not 0. My remainder is -252. On the back side, I want to determine if the following is a root solution x-intercept of the polynomial. So when it gives it to you like this, that is just the number that you use. So if you just have to determine if it's a polynomial, you could either use synthetic division or you could use substitution. Either method works. I'm going to use synthetic division and I'm going to check when x equals 1. So 1 is my number that goes over here. My exponents go in order. I'm going to bring my first number straight down, and then I multiply. 1 times 15 is 15. Add, get negative 17. Multiply. 1 times negative 17 is negative 17. Add, and you get negative 14. Multiply, you get negative 14, and add, and you get negative 12. So that last number right there, that's your remainder. So 1 is not a root because my remainder is negative 12, not 0. If you have to end up writing this, this is called a depressed polynomial. I'm going to put my variables back in. I started with x to the third. When I write my answer, it's 1 degree less, so that's x to the second, minus 17x, minus 14, minus 12 over x minus 1. So the denominator, you might need a little bit of help there. So remember, if you're only given the root and you have to write the linear, you just have to remember to change signs. I'm going to check and see if negative 1/5 is a root of this polynomial. And especially when I have fractions here. When I have fractions, I really like doing the plug it in, the substitute method, because then I don't have to multiply fractions here. I know that negative 1/5 is the same thing as negative 0.2. So I'm going to go ahead and turn that into a decimal. I have it in function notation. So I want to see what is the value of the function when x equals negative 0.2. So in place of x in my original function, I'm going to plug negative 0.2 in. There we go. So this is just how it looks when it's in function notation. So I'm going to plug this into my calculator. Try to get it out of the reflection. 15 times negative 0.2 to the third power. Minus 32 times negative 0.2 squared. Plus 3 times negative 0.2 plus 2. And I got 0. So you have to remember that whatever number that you get here, this is the remainder. So if it just says determine if a number is a root, I would be able to say yes. Negative 1/5 is a root because my remainder equals 0. As long as you just want to know if it's a root, this substitution method works great. But most of the time, you use this as a quick method so that you can finish factoring or solving the rest of the polynomial. So once a number works, then you generally have to plug it in and you have to do synthetic division anyway. 15, negative 32, 3, 2. So you bring your first number down, multiply negative 0.2 times 15 equals negative 3. Add down and you get negative 35. Multiply negative 0.2 times negative 35 equals 7. Add down and you get 10. Negative 0.2 times 10 equals negative 2. Add down and you get 0. Fantastic. That's what I expected to happen, because whether you do substitution or synthetic division, your remainder needs to be the same. So if I wanted to plug my variables in, that would be 15x squared minus 35x plus 10. And then tomorrow I would probably take this and I would finish factoring it down to find the other factors and roots of my polynomial. And the next one is just more of the same. So when it says find f of negative 1, this is saying x equals negative 1. So f of negative 1 means you would set it up as 2 times negative 1 cubed plus negative 1 squared minus 7 times negative 1 minus 6. I plugged all that into my calculator and I got 0. So it says determine if the roots are, if the following are roots of the polynomial. If it is, then you have to write the depressed polynomial. All right. So when you get an answer of 0, that's the good thing. So yes, x equals negative 1 is a root of my polynomial. So therefore, you have to come over here and run synthetic division so that you can take your depressed polynomial and do more with it. So my coefficients are 2, 1, negative 7, and negative 6. Bring your first one down, multiply, add, multiply, add, multiply, add. Put your variables back in. 2x squared minus 1x minus 6 is my depressed polynomial. My remainder is 0, so these are totally matching. That's a good thing. And then your next step from there tomorrow would be to either factor it or run the quadratic formula and solve it. And then I would do the same thing for these next two numbers.